Okay, I believe we are live. Hello and welcome to Stacklok Demo Day. I'm Luke Hines, your navigator in this digital quest for ironclad code. Here we don't just do the tech talk, we walk it, one demo at a time. From safeguarding supply chains to outsmarting cyber villains, we share the insider tricks every developer needs to know. So gear up, it's demo time. Today, I'm excited to introduce two of my esteemed colleagues, Yolanda Robla and Rado Dimitrov. Yolanda is one of our staff engineers at Stacklok. She's known for not only being a prolific open source developer, but also one of Stacklok's data scientists, having achieved a master's degree in data science at the University of Catalonia. Yolanda, being the rock star that she is doing this demo even though she's recovering from a nasty chest infection. So we're hoping that Yolanda's voice holds out for the duration of this demo. So how are you doing, Yolanda?
Fine.
And more importantly, did you drink your hot lemon tea?
Fine, doing well. I took lots of medication. And yeah, I believe the voice is going to be okay for the demo. Maybe it goes after that.
Good stuff. We'll see how it goes. But you're a real star for doing this. And Rado is a senior engineer at Stacklok. He's also a prolific open source developer, well known for hacking on many open source supply chain projects. Okay, so some of you may be familiar with Rado. You probably know Tough, the update framework. Tough underpins the trust in projects such as SigStore. Rado just completed a complete rewrite of the official open source Go version of the Tough library. Rado also works on Minder, our open source software supply chain platform that we're going to be seeing today, and is also helping develop the SigStore Go library. How are you doing, Rado?
I'm great. I'm happy to be here.
Good to have you. Good to have you. So, Yolanda, I believe you're going to kick us off and introduce us to what we're going to see today, and then you're going to crack on and show us the demo along with Rado.
Sure. So yeah, let me start sharing a screen. I will be showing our project that is called Trusty. Okay.
So this is trustypackage.dev.
Yeah, trustypackage.dev. Actually, is a web app that gives actually information about packages from different ecosystems. So if you are ever wondering, you are doing some programming, you want to start adding a new dependency, adding a new package, then you can check this website actually to get information about the packages that are more convenient for your code, like the packages that have more activity, are more reliable, alternatives for that as well. So we actually cover different ecosystems. We have like PyPy, like Python, NPM for JavaScript, Rust, Maven for Java, and lately we added Go support. That's actually what I'm going to be showing today. So yeah, let's select the Go ecosystem, and we're going to look for some popular package that is Kubernetes that actually is written in Go.
I've never heard of Kubernetes.
Yeah, who knows about that? Yeah.
Okay.
Okay, so here, yeah, you can see like this is the information for the Kubernetes package. Of course, it's a super popular, very well-known package. It has a very, very high score. So what do we show in Trusty? So first, for each package, we collect information about actually the package name, the package origin in this case. So in this case, you can see that the Kubernetes package is big, actually for Go. Everything is tied to a repo. So actually the package name and the repo are the same. And we get some information about the origin of the package as well. So for example, you can get the source origin of Kubernetes. You can take a look here. Latest version of the package. Some information so you can see how the package belongs, how the package is popular. So in this case, it's very, very popular. It has lots of stars, lots of open issues. In the right, we show also like the information about the author of the package. In this case, like it's a actually organization, so you can see the information about it. All the public repos that belongs to this author as well. And what's interesting about that, in the right, you can see actually that we are giving scores to each package. In this case, we do we have different techniques to give a score to a package. Initially, we really don't measure scores in actually mathematical way, or like getting scores about the code quality, whatever. We are doing more analysis about the activity, how the package is used by the community. So we start with some measuring some activity, actually the repo activity and the author activity. So repo activity means like actually how much stars the repo has, how many contributors, how many open issues. We do some analytics with that, like PCA scores for each of the components of the repo activity, and we do the same for author. For author, we track the GitHub, the followers, the gist, all the comments that the author has, and with that we do some analytics and we perform a score for it, so you can get an idea on how reliable the package is, the community behind it is,
and when you say PCA, Yolanda, that's principal component analysis. Did I get that right?
Principal component analysis. Yeah. It means that
you calculate the entire package ecosystem, and I remember you were able to see sort of malicious packages and packages that were close to deprecation, and so there's quite a bit behind this score, isn't there? There's quite a lot of number crunching.
Yeah, so in this case, mostly we're measuring the repo activity and author activity. We do typo squatting. Typo squatting means that there are packages that can be similar to others in terms of naming, and then it may be that they are trying to attack some other popular package. In this case, it's not the case, so we get a higher score on it. And we also do provenance. Provenance means that is the number or like the score that we give to the strength of the link from the package to the repo. In this case, for Go, we are pretty sure that the package belongs to a GitHub repo due to how Git and the Go ecosystem is built. So we also give a 10 on the score for that.
And we also look at SIG store as well, don't we? And something called historical provenance, which Nigel showed in the last stream.
Yeah, I mean, for Go, we just assume that, or we have the certainty that all the packages belong to a repo. For other ecosystems, I mean, we can show, for example, SIG store here. In this case, actually, for NPM, we have attestations, actually, that the ecosystem, the registry, is doing some proof of some verification that the package actually published in NPM belongs to the original repo. So actually, you can get some details here. Actually, this package is signed and with some certificates that actually gives you the right information about that SIG store belongs really to this repo, and that is not any scam, that you really can trust in this package. Yeah.
That makes sense. So I guess a lot of projects can effectively they can scam a score on a security scoring system by claiming to come from a repo that they don't actually originate from. So I could just create some project and then I could just stuff in that I'm from Facebook React, and then I'd effectively hijack all of the reputation of that project. But what we do is we try to pin to the source of origin to guarantee that matching. Gotcha.
Okay, so some more information that we can show also is about package activity and package deprecation, actually. So in this case, for example, we want to use etcd, that is actually a key value storage, pretty widely used. We want to have a library that gives us coverage for that. Okay, and we decide to use this library. We can come here to Trusty, and then we get the surprise that this package is deprecated. So we get the information here about deprecation, and actually there is some suggestion in the repo as well telling that it's deprecated. And then actually we, in the security checks, we can just get an alert here telling that there may be some problem. So we come here and we see, okay, this package is deprecated. We should not be using that. Or if we use it, we need to take care of this because it's not maintained. They may have CVEs or they may have other problems, and this repo is not maintained anymore. So what can we do after that? actually Trusty is giving us some suggestions on better packages that we can use with the same functionality. So for example, you can see, okay, I want to use etcd. There is a similar package actually that is giving us the same functionality, but with a better score. So we come here and yeah, okay, we click on the suggestion and okay, we see that we have a different package for etcd. It has better score. It has actually a lot of repo activity. It has also a good author activity as well. It's not deprecated, so then it's safe to use. Okay. Actually, with that, yeah, we can go to the repo. We see that yeah, it's actively maintained. We can trust on it. Okay, and then with this information with Trusty, we are also integrating with another project that we have that is called Minder, that is going to be using all this information that we are providing. We provide it into a web page, but we also provide this information via some API that can be consumed by our Minder project. And now my colleague Rado is going to show how can we actually automate this into our pull request to get actually code blocked if we are using a package that is deprecated or has not good activity. Okay, so then
Yolanda.
I will be passing to my colleague Rado, and he will be showing that. Thank you.
Great. So you're going to be showcasing Minder pretty much now, Rado? Minder integration with Trusty and other components.
Yeah, we'll try to put what Yolanda was explaining so far into actually practice through Minder. So the demo that I will be showing is actually relatively simple. We have a project that we contribute to. It's a simple Go application server. So this is the repository of the project. We can see that it's just essentially 2 handlers, and we start a server with that. And what we will show here is how you can leverage all of the functionality that Trusty gives you and create try to define a policy for your repository and for all of the dependencies that you inject. So you can kind of protect yourself from using something that is deprecated, something that is vulnerable, that has CVEs in it. And to do that, this happens through Minder. So Minder is this open source project that allows you to have to create profiles for your project. It's basically something like a Swiss knife. That's how I see it. You have this engine, and you can have rule types and profiles that it's up to you to create. And what Minder does is it ensures that everything is exactly as you want it to be. So in this case, for this repository, we want to create a profile that is checking all of our dependencies that we introduce through pull requests and verifying them against a vulnerability database such as OSV, and also verifying them against Trusty.
And OSV, what's that, Rado?
So it's the way I see it, it's a vulnerability database. So a huge list of all of the projects and their known vulnerabilities, like these CVE numbers that we see everywhere.
Right, gotcha, yeah.
And also the versions that are impacted by these CVEs and the versions that provide fixes for those CVEs.
Gotcha.
And it's good to have that in mind because Minder actually leverages that information, which we'll see in the example in a bit. So yeah, this is our simple Go application. The demo will be our typical everyday development process. So we have the project, we do some coding, we propose these changes through a PR, and we will see how Trusty with Minder can actually help us deliver a better code and also improve the whole posture of our project. So this is the project that we have. For the purpose of the demo, I have already prepared all of the coding and things that I want to showcase that I add to the project. So this is the main function that we saw in a bit before that. So this is how we extended it. We still have two handlers, but we now added additional things like logging, like so first we log the messages, like we log each call of those handlers. And we also added functionality, which is just a simple functionality, just for the purpose of this test, of this demo, that instantiates an etcd client, reads a value from that etcd database that we have. And in this case, this value is a name of a chart, a Helm chart table. And then we use another client, which is a Helm client, and we query that Helm client for all of the releases that happened for that Helm chart within that cluster.
I see. And so this is the pull request that you as a developer are going to push to that example repo.
Exactly. Yeah.
Yeah.
And that aligns very well with the example that Yolanda did before that.
Sure. So this is the pull request that's going to be scrutinized for security risks effectively.
Yeah.
Gotcha.
So this is me. I'm the developer. I have developed some codes. I don't care about the dependencies so far. I mean, I haven't thought about all the dependencies, the dependencies that I got. Maybe I got some through tools like all of these OpenAI models that we use to help us write better code, but we're not sure what to inject. So
makes sense.
That's also one of the benefits that this profile and Minder and Trusty will help. So
which is very common now. There's so much code generated by ChatGPT that folks aren't aware that those large language models have been trained on data that's not quite fresh. So packages can have been fallen out of maintenance, deprecated, abandoned. Yet these large language models can still make those recommendations.
Yeah, and also there might be a vulnerability in this model because someone might have trained the model to suggest you a package that is actually vulnerable.
Sure.
And if you are a developer, you can say, okay, write me a simple Go server application, but it might use a server library that is actually compromised.
So, understood. Yeah.
Yeah. So basically, this is the PR that we'll do. We have logging. We have this etcd function that reads a value from the etcd database, and we have this function that actually gives us all of the releases. We ignore the outputs. That's just for the sake of the demo. This is the rest of so this is what stands behind those functions. We have a Helm client, which uses the Helm library, the Helm package, the official Helm package. For logging, we use this library. And for etcd, we use this client, which is the client that Yolanda showed before, the package that Yolanda showed before.
Gotcha.
And this is our Go mode file. So what we'll do now is, this is our current repository state. So we'll add everything and we'll commit the code. Implement, yeah, I have tested that before so you can see the history, but implement some feature. That's our commit message. We commit, and then we want to push our branch feature. So what we have now is we go back to the website, basically to our repository, and we see that we have pushed this new branch there. And we want to open a pull request. So we open a pull request. And we should be able to see how actually what Minder does behind the scenes. So we opened a pull request. And what Minder did is he got an event for that pull request, and he scanned all of the things that we try to introduce to this project. So all of the content that we try to add as dependencies to our project. And it commented that it uses my name because that's how I subscribed to Minder. That's how I created my account profile, but this can be your name in your case. And so what is the comment? What it comments with is an output of the summary for all of the dependencies that we introduce and how they actually, how to say it, how they score with Trusty. So we show a list of all of our dependencies and their Trusty score. And also we show if some of our dependencies are introducing known vulnerabilities. So what happens is we scan all of the dependencies that we introduce, we check them against Trusty, we get the Trusty score there, and the profile that I have created for my repository is that I don't want to introduce dependencies that are scored below a certain threshold in Trusty. In this case, this threshold is around 6.5. So I see that one of my dependencies is actually flagged, and it's exactly this etcd dependency. And what Minder does is actually suggests you to use another version which is higher, which is scored higher. The same thing happens for another package that I use, which is the log package. And that's all of the that's the result of the Trusty verification. I have also enabled another rule type within my profile, which is this vulnerability database verification, which gets, again, the list of my dependencies and check if the versions that I want to use have known vulnerabilities. And if there are, suggests fix for me that I can use to remediate that vulnerability use. Basically, that CVE to not exist. So in this case, I have explicitly used an older version of the Helm package, and Minder codes that, and it suggests another version, which is 14.2, which doesn't have that CVE. And if we go to the OSV database, we can see that, so this is the package that I'm using, and there has been several CVEs for that package. Of course, it's a known package. So we can see that this is a CV, for example, that is fixed in that version, 3.14.2.
Nice.
So what we can do,
go ahead. Please go ahead. Yeah.
So what we can do now is we have opened a pull request. We saw that Minder processed all of that, and it outputs us with some suggestions or even with some direct fixes about it, about what we're trying to introduce. So what we can do now is we can actually just accept the changes for the Helm package. And we can see that this automatically triggers another evaluation of our profile that actually says, you know what, Minder didn't find any vulnerabilities that are part in the OSV database. So, of course, we want to do better than that. So let's see how we fix also the Trusty issues. So for that, we have to update our dependency. This is not something that Minder can do automatically because the API between the libraries might be different.
I was just going to mention at Rado at this point as well that there's some work, isn't there, to make more of a, where the Minder found the vulnerability, there's like some rich text that gives you details about the vulnerability and the formatting. I've seen some work going on there. So folks at home, you'll actually see quite shortly, you'll see a kind of a rich definition about the vulnerability that was found and some contextual information. And the other thing I was just wanted to highlight upon is, this is really accurate, the recommendations it's come up with. Yolanda, what's happening behind the scenes there for these alternative recommendations?
So yeah, actually we are using some LLM to actually, we get LLM information about the package name, get also some description to get provide some idea of the functionality, and we are also using the common knowledge from LLMs to get the suggestions about that.
Cool.
Then we normally get a list of results And with that, we curate that the results actually make sense. We check that the package really exists and that the package has higher score actually than the one that we are trying to solve.
Yeah.
And that's the one with those alternatives we are providing this information actually to Minder.
Makes sense. And I guess the really cool thing is as well is we pass those LLM suggestions back through the activity checks and so forth. So if the LLM was to recommend a bad package as a replacements package, our system would actually capture that. So we vet the recommendations as well coming out of the LLM. So we're not just blindly putting out LLM recommendations, we're running them back through our own engine as well. That's awesome. Okay, sorry, Rado, you're going to fix up your pull request now.
Yeah.
Cool.
So I forgot to say that in that Trusty table, if someone is interested to understand why Minder is suggesting to replace this dependency with something else, all of these entries in that table are hyperlinks to Trusty, so you can just click and see, hey, you know what? This package is scored with this. You can see the details. It doesn't have a lot of activity in it.
Yeah.
So for the logging package, of course, the etcd package is relatively straightforward. We don't want to use anything that is deprecated, so we use the suggestion that Trusty gave us. For the log package, we have two suggestions. I will use the zero log one since it's something that I'm more familiar with, but the method is the same. So we go to the code.
I have already. Sorry, Rado, didn't mean to interrupt you, but you can choose what you are comfortable with for an activity score when you set the policy. Is that right? So some folks might be quite happy with a 5 or a 6, or so you can dial this in.
Yeah, I was planning to show that at the end, but basically this is the profile. This is how simple it is to configure such policy for your repository.
Gotcha.
So this is the Trusty part, and this is the vulnerability check part, which is currently configured to use OSV and to use Go. It's good to note here that we not only support Go, we support also Python and NPM. So you can do that same thing for your NPM project. So yeah, we are back to trying to fix our PR.
Yeah.
For the purpose of the demo, I have prepared a code that is already created. So I will just uncomment the functions and the new dependencies that I want to use. So in this case, this is the zero log dependency that I'm trying to move from. Oh, and actually I forgot to, yeah. So let me just check out quickly. And I forgot to pull the latest changes that Minder did to the PR. So what I do is I'll just fetch the latest remote. I see that there is one commit. I will pull it. And I see that there is an update to the Go mode file that Minder did in the PR. So now I'm back to my code. I will quickly fix all of the usages of the libraries that Trusty said that they're not okay. So this is the logging part. We also had problems with etcd. I'll comment my, just a second. So what I did now is I switched to using the libraries, the packages that Trusty suggested, those entries in the table. So what I have now is I have my updates ready. I will do go mode tidy just to be sure. These are the changes that I want to introduce. And what I will do is just add all of those changes and commit. And my commit message is use the proper etcd and logging packages. So I have committed, I will push. And on the PR side, we can see that Minder again caught this update, analyzed it, and based on the profile that I have, resulted this output that there are no trust issues that we found, and there are no vulnerabilities that I add through adding those dependencies. And I think I'm right on time. I'm sorry, it took a bit more time.
That's great. That's great, Rado. And it's working very zippily. It's very quick to respond. So for the folks at home, this is event-based driven, isn't it? So effectively, we can respond in real time to thousands and thousands of repositories. So this is on the public instance, I guess, that we run at Stacklok, which anybody.
Yeah, exactly. This is what everyone can do at home. So.
And it's an open source project. It's Apache 2 license. So folks are welcome to come along and have a look at the code. I believe there's a quick start on this. So if you wanted to get involved quick, try it out quickly, you can just run a series of quick start commands. Brilliant. Okay, well, that brings us to the end. Thank you, Yolanda and Rado. Great to have you here. Yolanda, well done with your voice. You did brilliant. And Rado, thank you so much. So folks, if you're interested in learning more, the best thing to do is head over to stacklok.com. On there, you'll get links to our community Discord where we all hang out, and you'll find the various social media links to follow us, and where our GitHub page is, where our GitHub organization is, where you'll find a lot of our work that's happening. So thank you for joining us, and until the next time, stay safe and stay happy. Bye-bye.
Bye.
Bye.